In this screencast, we'll be reviewing carboxylic acid and carboxylic acid derivatives. First, we'll go over the synthesis of carboxylic acid, which includes oxidation and ozonolysis. Next, we'll go over the reduction of carboxylic acids from those reagents. And lastly, we'll go over the synthesis of carboxylic acid derivatives starting from carboxylic acids. First off, it should be mentioned these are all the carboxylic acid derivatives. We have nitriles, amines, acid chlorides, acid anhydride, and esters. And this is a carboxylic acid. Amines are the least reactive, and acid chlorides and esters are the most reactive of the derivatives. It should be mentioned that any of these derivatives can be hydrolyzed back into carboxylic acid using this. So for oxidation, these are the reagents. KMnO4, O4, HNO3, and Na2Cr2O7 will all synthesize carboxylic acids. Ozonolysis. Here's an example of an ozonolysis reaction. If we take this alkane and we use O3 and H2O2, we'll yield a ketone and the carboxylic acid. That's an ozonolysis reaction. For a reduction of carboxylic acids, lithium aluminium hydride, boron hydride, and B2H6 are all examples. So if we start with this carboxylic acid, and we use lithium aluminium hydride, also known as LAH, in the presence of water, it'll synthesize this carboxylic acid back into this, just an alcohol. Okay, the same goes for BH3. So BH3 would do the same thing in the presence of water, but you would need an aprotic base for BH3 like THF, and in the presence of water. So B2H6 is a different story though. It uses or it's selective for carboxylic acid. So if we take, this is a good example because of how it's selective for only carboxylic acids. If we take this this carboxylic acid and just this ester, and we treat it with B2H6 in the presence of an aqueous workup, this will be the final product. This alcohol will be formed just like above when we use LAH, but this time the ester will be left alone because it's selective for just the carboxylic acid here. So that's a very interesting way to reduce carboxylic acids. Next, we'll go over the synthesis of amines from carboxylic acids. Actually, no, we'll go over esterification first. So Fischer esterification will be our first example. Let's take this carboxylic acid in the presence of HOCH3 and H2SO4, and this will be the ester formed. Next, we'll go over the SN2. If we take this ester, or this carboxylic acid, in the presence of NaOH, first we'll use NaOH, and this will be the product. Now we treat it with CH3 iodine, and this will just undergo a standard SN2 mechanism, and that will be the ester formed. Lastly, diazomethane is the last esterification we'll go over. Let's take the standard carboxylic acid, treat it with CH2, N2, and again, this will be the product. So these are all esters, carboxylic acid derivative esters. Finally, we'll go over amine synthesis. We have primary, tertiary, and secondary amines. And for all amine reactions, two equivalents will be needed. So here is the amine section, or amide formation. Take the standard carboxylic acid, treating it with a secondary amine in the presence of heat. This will be the product. And then some R and an H. Finally, we can sum up this unit with a reaction wheel. Starting with carboxylic acid, H2SO4, and ROH will synthesize an amide. Next, we will go over another esterification. This was the diazomethane esterification. And then CH3 iodine is the final. In the next screen record, we'll go over acid anhydrides and acid chlorides, which are very applicable. This was amide formation. So that's all we covered. And then we also covered synthesis. So if we take KMNO4, oh wait, no, this wouldn't be applicable to this. And then that's what we went over. So, synthesis, right? So KMNO4, you would need this group, and then it would form carboxylic acid. We went over ozonolysis and reduction. And again, all these derivatives can be reverted back to carboxylic acid using hydrolysis.